objective for this next lesson is going to be 1.3. I can multiply and divide monomials. And monomials are expressions that only have one term. So that means there's no multiplying and there's only multiplying and dividing an exponents, but there's no adding or subtracting because it's only one term. So first we're going to look at how to multiply monomials. So I'm going to write multiplying monomials. And we're actually going to look at some examples first and then see if we can figure out what the pattern is. So for the first example, let's do x to the third times x to the sixth. And so I'm just going to write out expanded what this means. So x to the third I know means x times x times x. And x to the sixth means x times x times x times x times x times x. So I should have, 6 factors there. So now if I simplify this, this would simplify to x to the 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 factors of x, so it simplifies to x to the 9th. The second one, let's do y to the 4th times y to the 2nd. So I'm going to write out in expanded form what this means. So this means 4 factors of y, so 1, 2, 3, 4 factors of y times 1, 2 more factors of y. So now if I simplify this, I have y to the 1, 2, 3, 4, 5, 6th power. And then for the third example, let's do a to the 2nd times a to the 3rd. And so that means I have 2 factors of a times 3 more factors of a. So if I simplify, I have 5 factors of a, so it's a to the 5th power. So let's look and see if we notice a pattern and then come up with a rule. So I'm going to write out when you multiply powers with the same base, they have to have the same base for this rule to work. We do something with the exponents. So let's look and see if we see a pattern. These all have the same base, they're both x's. These have the same base, they're both y's. These have the same base, they're both a's. So the pattern is, when you multiply powers with the same base, you're going to add the exponents. 3 plus 6 is 9, 4 plus 2 is 6, 2 plus 3 is 5. So you're going to add the exponents. So remember, we're really multiplying here, but the shortcut is to add the exponents, and we're going to do some more examples. So for example 4, I'm going to put 6p to the 2nd times negative 4p to the 5th. And remember, we're really multiplying. The shortcut is adding. So this means 6 times p times negative 4 times p times p times p times p times p. So if I simplify this, 6 times negative 4 is negative 24. And then I have 1, 2, 3, 4, 5, 6, 7 factors of p. For the next example, I'm going to do 3d to the 4th times 5d. And this really means 3 times d times d times d times d times 5 times d. 3 times 5 is 15. And then I have 5 factors of d, so d to the 5th. And if we use our shortcut, we can check our work. 3 times 5 is 15, and 4 plus this is really d to the 1st will give me d to the 5th. We're going to do one more multiplying example. Let's do 4m to the 2nd times n to the 3rd times negative 5m to the 6th times n. And remember, the rule we said, this rule right here, only works if you're multiplying powers with the same base. So I can only multiply m's times m's and only multiply n's times n's when I simplify. So this means 4 times 2m's and 3 factors of n, and then negative 5 times 4, 5, 6 factors of m and 1 n. So when I simplify, 4 times negative 5 is negative 20. And I have 1, 2, 3, 4, 5, 6, 7, 8 factors of m, and 1, 2, 3, 4 factors of n. And if we check our work, 4 times negative 5 is negative 20, 2 plus 6 is 8, and 3 plus 1 is 4. Let's go on to dividing monomials. So I'm going to put dividing monomials, and we'll do some examples. For the first one, this will be example 7. We'll do x to the 5th over x to the 2nd. So that means I have 5 factors of x on top, 1, 2, 3, 4, 5, and 2 factors of x on the bottom. And then I notice that x divided by x is going to be 1. Anything divided by itself simplifies to 1. So this simplifies to 1, and this simplifies to 1. So if I cross those out, I'm left with 3 factors of x. So I can simplify that by saying x to the 3rd. Then for example 8, let's do b to the 8th over b to the 3rd. So that's 1, 2, 3, 4, 5, 6, 7, 8 factors of b on top, and 3 factors of b on the bottom. And then b divided by b is 1, b divided by b is 1, b divided by b is 1. So I'm left with 1, 2, 3, 4, 5 factors of b on the top. So if we look at this, we want to see if we can figure out a pattern. We'll write that rule right here. When you divide powers with the same base, what do we do with the exponents? Well, 5 minus 2 is 3, and 8 minus 3 is 5, so you subtract the exponents. We're going to do a couple more examples using this rule. So for the first one, for example 9, let's do 49 x to the 6th over 7x squared. So I have 49 times 1, 2, 3, 4, 5, 6 factors of x divided by 7 times 2 factors of x. 49 divided by 7 is 7. X divided by x is 1. X divided by x is 1. So I'm left over with 4 factors of x, so x to the 4th. And if we check our work, 49 divided by 7 is 7. 6 minus 2 is 4. Let's do one more of these. So let's do negative 12 a to the 6th, b to the 8th, divided by 4 a squared b. So this means negative 12 times 1, 2, 3, 4, 5, 6 a's, 1, 2, 3, 4, 5, 6, 7, 8 b's, divided by 4 times a times a times b. Oops, I need to move up so you can see it. Negative 12 divided by 4 is negative 3. And then I'll look for things that can become 1. A divided by a is 1, a divided by a is 1, and this b divided by b is 1. So I'm left over with 1, 2, 3, 4 factors of a, so a to the 4th, and 1, 2, 3, 4, 5, 6, 7 factors of b. And if we check our work, negative 12 divided by 4 is negative 3, 6 minus 2 is 4, 8 minus 1 is 7.